Hello. Um, my name is Claus Ibsen, and welcome to this talk about Camel, Fabric8, and Kubernetes. I was here in 2011. Back then, I was not very good at taking photos, so the only photos I managed to take was of your famous Freedom Monument. So let's try to do a bit better. So let me take a photo now. Hello, 1, 2, 3. Thank you. Now my mom will be happy. Okay, so I worked for Red Hat as a software engineer. I've been working a lot with Apache Camel. Also wrote a book on Camel and currently writing the update of that book, second edition. It's a lot of work to do a book. But also in the recent couple of years, I've been working more with cloud technologies like Kubernetes and Fabric8 and so on. So how many here in the audience is already tried and used Camel? So for the video, that's maybe 10, 20%. So there are some people that are new to Camel. That's good. So let me just give you a quick demonstration of Camel. And for that, I'll just build a little example. So suppose you need to search for tweets with a certain keyword and then upload those live on a web page. How can you do that? Well, the example will be something like this in a graphical representation, do Twitter search and then send to a WebSocket that the web page can listen on and then upload the web page. So with Camel, all you need to do, the ingredients with Camel is that you need to get hold on Camel Core and the Camel Twitter component. Then you can write 2 Java classes and have an HTML page and a Maven POM file. Okay, so this is a microservice in Camel, famous word. So this is just a public static void main application. And we have up here a main class that is actually a main class from Camel that allows you to easily boot Camel in standalone. Then we configure Twitter because you need some credentials and tokens to be able to access Twitter. Then we specify what we want to search for. And I wanted to use a popular search term, even though dev is a good term here, but apparently you guys are sitting now and listening instead of tweeting. So we had to use something else. So I chose Adele. She's a famous singer from England, so probably some people talking about her. And then the port number for the WebSocket and so on. And we add a Camel Route and then we run it. And for the second class, we need to configure the WebSocket component with the port number and the Twitter component with these credentials to be able to log into Twitter. The Camel Route, that is where the meat is. That is where the heart of the problem is. So actually what you do in Camel, you specify a route that starts from Twitter. I do a search and with some parameters. And one of the parameters is the search term. That is the keyword we are searching for. Then we log it, which will log it to the console you're running. And then we push it to the WebSocket component on a channel called Camel Tweet. And we want to do that in a public subscribe way. So we enable the send to all option. The HTML file is just a standalone HTML with some JavaScript. It uses WebSocket on localhost 1990 on that channel. And then there's an on message and some script here to show that on the web page. The Maven POM file is just the dependencies, Core, Twitter, and WebSocket, and some logging libraries, and you're ready to go. So let's try that. Kill the slides, go live, and there is a Maven goal up here that allows to run a Maven project using exit Java. So it starts up the Camel application. There's some logging here. And let's go to a web page on 1990. And hopefully this page will show maybe sometime that people will tweet about Adele or not. It pauses every 5 seconds, so hopefully there should be something. Or maybe not. There's a little bit there. I was too late. Here, yeah. You can search for other terms on Twitter that are much more popular to tweet about, but because this is a video recording, we can't really search for these, so let's go for just that. And just to show something else is that there is a little tool called Hot.io. You can run from standalone as well. That boot up another JVM that is a web console that allows to look inside other Java applications. So this is a different JVM. We have one JVM with the Twitter application, and then we have this JVM with Hot.io. and a web browser, and there's a tab here called local, so I can look on my laptop what Java JVMs I'm running currently. And down here, that is the Twitter application running using XJava, and I can click a button here and connect it to that application using a Java JVM agent. Now I'm looking inside that Twitter JVM, what is going on. And Hot.io has plugins for different Java applications. There's one for Camel, yay. And so I can actually list the camels inside that JVM. And there's a Camel Route here, and I can click this one. And we can get a live visual representation of our Camel application. You can see this is the Twitter and the log and the WebSocket. And 47, that is the number of tweets that it has been able to capture, 47 tweets so far. And these numbers will be updated in real time, 53 and so on. And there are plugins for different JMX. It's a standard JMX, and you can see the threads and so on. And you can build your own plugins inside Hot.io. But the Hot.io is a nice visual representation of what's going on with your Java application and Camel, etc. But that was just a quick early demo of Camel. So let's leave that alone and go back to the slides. I hope you guys are a bit wake up now. And we continue. So, Camel. Now let's change focus a bit and talk about something also very popular recently, cloud technologies such as Kubernetes and Docker and so on. And for that, we have to talk a bit about Docker. So a couple of years ago, Docker emerged in the open source industry projects and became very popular. It made it much easier to use Linux containers and run them and build them and so on. I'm pretty sure you guys have heard of Docker and seen it before and whatnot. This talk is not so much about Docker, but just saying that Kubernetes is based on Docker. Now, besides Docker, in the last couple of years, a lot of other related products has emerged on the scene. DICE, CoreOS, Red Hat OpenShift, Cloud Foundry, and Kubernetes itself, which is what I'm going to talk about, and Docker Swarm, and Apache Mesos, and many other products. But the thing I will talk about is more focused around Kubernetes and a bit about OpenShift. So at the bottom layer, we have Docker as the container virtualization, but running a container using Docker, when you need to run that in a cluster with multiple nodes and whatnot, you need something above Docker being able to orchestrate and manage that. And that's where you need an orchestration and scheduling platform, and which is something like Kubernetes is able to do. Now, on top of Kubernetes, you can use a product such as OpenShift, which is a platform as a service. So what OpenShift adds on top of Kubernetes is additional things such as a web console. It has security, user management. It has a private Docker registry you can run on-premise internally. It has a continuous delivery pipeline platform. It has a build management and other things. Kubernetes by itself is pretty bare bone how you interact with it. It has a REST API, and then it has a command line interface, and that's it. So that's where you can say there's some products that build value add on Kubernetes, such as OpenShift. But there was also a product I mentioned, Fabric8. So what is Fabric8? That's a good question. Is Fabric8 sort of between Kubernetes and OpenShift, or is it on top of OpenShift, or is it on top of Docker and whatnot? No, it's not. We kind of like to picture Fabric8 as sort of on the side. So Fabric8 provides a bit for everything. We say that Fabric8 provides service and tools for Docker, Kubernetes, and OpenShift. In Fabric8, we have tools so you can build Docker image, and you can also use Maven to run Docker containers and stop them and pause them and whatnot. It's able to build Kubernetes manifest files, which you need to use when you need to interact with the Kubernetes clusters to deploy things or scale things up and down. And for that, you specify a Kubernetes manifest file, which the Kubernetes platform understands. But these manifest files can actually be quite big to write, and that's where sometimes you need tooling to assist you. And for the OpenShift itself, Fabric8 provides some tools for those guys as well, especially around for Java developers. So sort of to summarize, Fabric8 and Kubernetes, this is the main focus of the talk, and a bit about OpenShift. Okay, so after lunch, another exercise. How many people have heard about Kubernetes? Oh, just as many as Camel, or maybe one more. So we need some catch up to do with Kubernetes and Camel. Okay, so even so that Docker made Linux containers very famous and easy to use a couple of years ago, it's not a new concept. For example, Google by itself has been running Linux containers for more than 10 years. So if you're using some of the Google service like Gmail, you may not aware that every time you run your own Gmail, it will actually spin up a Linux container for you personally with your Gmail. So they've been running that a lot internally, and what they wanted to, using a system called Borg, and Google wanted to rewrite Borg because over time a system always becomes worse and worse, and they have gained a lot of experience, so they wanted to rewrite it. And thank God they did that in open source way, so they published that in the open source community, and that's Kubernetes. One key feature of Kubernetes is that it's based on a desired state. So the idea is that to declare what state you want the cluster to be in, the happy state. So you say to the cluster, I want 5 of those and 10 of these and between 7 and 11 of those. And you can also specify limits on the resource, how much memory and CPU and so on they're allowed to use. So then you leave it up to the Kubernetes platform to figure out how to manage and run these. And it does that, so it sort of supervises the cluster and then figure out this is the desired state, and is there sort of like a gap in between? Do we have too much or too little? And then it actually reacts and figure out what to do. And because of that, you actually have this self-healing out of the box. So if, for example, a node with some Linux containers running and they crash, then the desired state is here, and then the actual state is here. Then the platform figures out, okay, what should I do? Should I run these Linux containers on another node? And then do that. Kubernetes also allows it very easy to use service, so an application can expose a service, which is very easy for clients to discover and use. So the architectural diagram of Kubernetes is something like that. You will have a highly available master here. It has the registry of your applications and whatnot. And then the master is the guy that sort of orchestrates and manages a cluster of nodes. And Minion, that was the old name we used, Kubernetes used for a node. Now it's called a Kubernetes node. Then inside the node, you run Docker containers. And these Docker containers are actually run inside something called a pod. A pod is a term from Kubernetes, so let's take a look at the terms that you should be aware of when you use Kubernetes, the key terms, the key concepts. And pods. A pod is just a group of Linux containers or Docker containers. So it can be one Docker container, or it can be 2 or 5 or 10, but they are sort of a group. Then there is something called a Replication Controller. That is the guy that actually manages these pods, the life cycle of them. It can spin up new pods and it can tear them down and so on. Then there's service. You use service to be able to communicate between your application or your pods. Then Kubernetes has something called labels. A label is just a key value pair. And you can label anything inside Kubernetes. So you can stick labels to anything. So you can stick labels to your pods, or replication controller, service, and whatnot. And the idea is that, for example, if you have some applications in the cluster that run Camel. So you can associate Camel as a label to pods and replication controllers. And by that, you can actually query the cluster and say, okay, what are the running pods that has Camel? And it can show you to them. And you can have multiple labels, so you can specify multiple selectors in that query. And Kubernetes also comes with the concept of namespaces. So the idea is that you can sort of have pods that run in the same namespace that are sort of together in the same virtual cluster. And then you can multiple namespaces, and they are sort of separate by each other. So you can sort of like have a virtual cluster in the physical cluster. Coming back a bit to pod. So a pod is a collection of Docker containers. They run on the same host, and they share the same life cycle. So if one of these Docker containers dies, then the pod is regarded as died. So they sort of stand together, and they can communicate internally with each other without going over the network. They also share the same volumes and whatnot. But the cool thing about Kubernetes is that they also share the same IP address and local ports. So that means that you can have a pod running on a physical node, and inside that pod you can maybe run Tomcat. And that Tomcat, you can choose to expose that on port 80. But on the same physical node, you can run another pod that also has Tomcat. And that Tomcat can also use port 80. So you don't have any port classes whatsoever. And you can decide freely which ports you want to use. There's no strings attached. Versus some other container manager. They have the idea that on a physical node, they run sort of like a daemon. And that daemon is in charge of assigning dynamic ports to your containers. And that is not so good. Then every container has dynamic ports, and you need to look them up and whatnot. That's not the case with Kubernetes. The port numbers are fixed. Replication Controller, that is the guy that is able to manage these ports, so it can scale them up and scale them down and rolling upgrades and so on. And the Replication Controller is sort of the guy that runs in the master of Kubernetes and look on the cluster and see if there's some missing parts, it can scale them up and so on. A service. So let's step back a bit. So you have an application running as a Linux container in a pod, and you want clients to be able to call your application, and for that you use a service. So the idea with a service in Kubernetes is that it's also an IP address and a port number, and it stays the same for the entire life cycle of that service. So you as a client only need to look up and get that service or that IP and port number one time. When you got hold of that, every time you want to call that service, it's the same IP and port number. It never changes. But the application that hosts the service running in the cluster inside these pods may be running on different nodes, and they may die and spin up on another node and be in a new pod. So their IP address may change, but the service does not. So the service is constant. It stays the same forever. And that's freaking awesome. So what about Fabric8? I have a t-shirt with that. So Fabric8 is an open source project on GitHub, Apache license, upstream, and whatnot, that provides a number of services and tools for OpenShift and Kubernetes. For example, with Fabric8, we do provide something for management. So if you have some DevOps guys that like these dashboards with centralized logging and graph that sort of aggregate the utilization of your clusters, then we have some applications for that. And they are using popular open source products such as Kibana and Elasticsearch and Grafana and so on. We also have a continuous delivery workflow that is using Jenkins pipeline. So for example, you can create a workflow that triggers on a Git push and then it runs in the multiple stages. The first state may be to do some unit tests. The second state may be to spin out a new temporary namespace in Kubernetes clusters, create some pods, and do some live integration tests between these pods, assert everything is okay, and if everything is okay, tear down that namespace and all these pods as if they have never been there, so it's totally clean up of all these resources. Then it may go to the next stage. That stage may be a human approval stage where someone has to click a button or reply an email or something that before it continues to next stage where it might be able to do a rolling upgrade on a pre-production environment and so on. There's also something called iPaaS, and it's called Integration Platform as a Service, and is heavily inspired and based on Camel. So there are actually a demand for that in terms of Camel for doing integration, but with less of a Java developer. So we get feedback that they want to do integration, but more in a way of being able to do it from a web console where you can sort of drag and drop a few components and do some connection. So we are working on that. And the tooling part, that is the focus of this talk. There are some tools you can use from a Maven developer to build Docker containers and generate Kubernetes manifest files which you need to use to deploy things into Kubernetes. And there is also some quick starts you can run on your laptop to easily try some of these examples. Okay, so let's try to see how you as a Java developer, how many here in the audience are Java developers or heavily Java developers? Okay, good. So you are the right spot. Myself is also Java developer. So you as a Java developer, if you have to get started on this container world, how do you do that? So let's try to build a microservice and get it running on Kubernetes. So to make the microservice very easy, it's just a hello service, and I like Camel, so both the client and the server, so to speak, is a Camel-based application. The idea is that you call the service with a name, and it returns some reply to you. Very simple. And to implement it, we can run Camel in a Tomcat application, and the client that calls this is a Camel standalone using Java CDI, and we use HTTP as the transport. So we have the hello service here, and in Camel Route, so to speak, it has a from servlet and do a message transformation on the client. It's a timer that calls the HTTP and then a log. And here is sort of the meat of the sauce. The Tomcat application is based on a Camel Route that is defined in an XML file. So it's from servlet, and then we do a message transformation where we say something, hi, I am, and then we want to show the host name of the Tomcat application. And because we're going to run it in a dynamic cluster, right? So there might be different host names. The client application is simple. It's from a timer that runs every 500 milliseconds. Then we want to call the service with a different name each time. So we call a Java method that has a counter bean. So there's a new counter every time. Then we call the HTTP endpoint using a component that is based on Netty HTTP on localhost 8080, and then we log it. The counter bean is just something saying reget day, and then the counter. Okay, now we are ready to run this. We can run it locally, one JVM running this, another JVM on Tomcat, and everything is hunky-dunky. They talk to each other. But we want to run it in Kubernetes in the cloud platform. So to do that, we need to use Docker. And to run Docker, you need to build a Docker image. And how do you build a Docker image from a Maven project? You can use a Maven plugin called Docker Maven plugin. Surprise name. So to do that, you have to go to the POM file and add the Docker Maven plugin and then do some configuration of it and also a few properties. It's actually not so super easy to build a Docker image because it depends on what you're running inside it, especially with Java. Is it a Tomcat application? Then you might need to have a base image that has Tomcat. If it's JBoss Firefly, then a different base image that has Firefly. Is it Spring-Boot and so on, and Java main and so on. And in the Fabric8 project, we do have a different base image you can use for different containers. So if you run this on your laptop, for example, you can use the Maven clean install and Docker build command. And then it will actually start to build that Docker image. And the green stuff you see here is actually from Docker itself, if you're actually using the Docker CLI command directly yourself. Then it will build that image and put it to the local Docker registry. And you can use the Docker command for that Docker image. And let's suppose you build the Tomcat application and the CDI application. You can see both. You have one for CDI and one for web. Now, you might think we are ready. So we have the Docker image of the CDI application, and we have the Docker image of the Tomcat, and we should be ready to go. Frankly, we are not, because we go from a sort of like a local static environment to a more dynamic platform, where your Docker containers can be run on different ports and different nodes and whatnot, so it's more dynamic. And we had actually, in the client that was calling Tomcat, we had specified the address to be hardcoded as localhost :8080. And that doesn't work in a dynamic environment. It was hardcoded. So what should we do? This is where you can win a bear if you actually have paid attention and is not totally confused. Yes, almost. As I said, we should use one of the most overloaded terms in computing, a service. Oh, sorry, here. We should use a service. So what is a Kubernetes service again? Well, you use a Kubernetes service to talk to your applications. And the service is actually just a network connection to one or more ports that host your service. And the network connection is again an IP address that has a fixed IP and a fixed port. So as a client, we need to get hold of that service. We need to get hold of that fixed IP and port. Then we can call the service. And now it gets a bit tricky. This is how sort of what happens. So when you deploy an application to Kubernetes with a service, that service gets enlisted in the Kubernetes master registry. And the master registry is able to push changes to any existing running nodes about changes in service. And on each node, there's something called a kube proxy running that can listen to these changes. So the kube proxy knows every time where all the services are and which ports are actually physical running that has the service. So when you as a client want to call a service, what happens at real time is that you end up calling the kube proxy. So the client thinks that you call a remote IP port number, but what happens at real time is that it calls the local kube proxy inside Kubernetes, and the kube proxy decides what to do next. The kube proxy knows where all the running ports are, and it chooses one to call. So you have this level of indirection between the client and the server. So from the client endpoint use point of view, all you need to do with the Kubernetes is to get the service, IP, and port, and you can use that. So how do you define a service? So the Tomcat application, we need to define that we have a hello service. And for that, you can specify 3 lines in a POM file, the name of the service. Then you need to specify 2 port numbers. The container port, that is the inside the Docker container. That is what is the service actually using internally. And because we are using Tomcat, and Tomcat out of the box comes with port 8080, then we use 8080. Then the service port, that is this IP port number you want to use outside the clients are using. And you can choose any one. I have before said you can choose 80 if you want, but you can choose anything. So I was just saying, okay, I choose 8282, but it doesn't really matter. It's a fixed port number. You have already decided that this service called hello is using port 8282. The only missing piece that the client needs to know is the IP number. So how does the client get hold of that IP and port number? So what happens is when Kubernetes run a Docker container in a pod, then it injects all the service as environmental variables in pairs of hostname and port using service host, service port. So here is the hello service, this is the hostname, and this is the port number. So you as a client should just be able to look up an environmental variable to find that service. You do not need to have a Kubernetes jar file in your client library as in Java and use that to look up the service. That's totally decoupled. All you need to do is look up environmental variables, which is easy to do in Java, Scala, or Python, or whatever programming language there is on the planet. They can look up environmental variables from the OS. Now, in newer version of Kubernetes, you can also expose service access service using DNS naming. So in the future, you can actually just say, I want to call a service called hello, and it's on http://hello:8282, and you're ready. Okay, so what we need to do in the client application is to change from localhost to call a service. So in Camel, you can use this notation of squirrely, service, and then the name of the service. Then Camel under the hood will do the environmental variable lookup for you and put them together. So this is all you need to do in the Camel application. So with this code change, then the client and the Tomcat application are ready. We can build them and run in the cluster. Okay, but how do you actually deploy something, a Maven product, inside a Kubernetes cluster? So you have your Java code, and you think it's ready to run in that one, but how do you get it there? There's also a Maven plugin for that. It's called Fabric8 Maven plugin, and it has a goal called apply. So when you make changes in the Kubernetes clusters, the idea is that you take a manifest file from Kubernetes and you apply it, and then it reacts accordingly. And that's why the goal is called apply. It's not called deploy. Okay, so what we have done in the Fabric8 project is that we have specified a Maven profile to make this deployment even easier. So we can just type Maven, then the profile, Fabric8 local deploy. And local deploy means that it will build the entire product, build the Docker image, push it to local Docker registry, and deploy it inside the Kubernetes cluster in one command. So we can do that for the Tomcat application and the CDI application, and we should be ready. Okay, so let's leave the slides a bit and have a bit fun with demos. So we go here. So I have here, it's probably big enough up here. So what I have here, I have a Vagrant image that is running a local installation of Kubernetes and Fabric8 and OpenShift together. It's more or less just to check out the Fabric8 installed product from GitHub, go to this directory and type Vagrant up, and it starts it. Then there is an OpenShift command line tool. You can run it from your shell, type OC get pods, for example. And this command then show you all the running pods in the cluster. And the names here are, you can see they have a dynamic name here. The idea is that, for example, myweb/something. So when you deploy something in the cluster, then there's a convention that all the names should be sort of random, unique, in the sense that you should not have fixed name of any of your applications because it's a dynamic world. So that's why it by default gives you these prefix on your pods. So myweb is actually the name for the Tomcat application. So we have one Tomcat application running here. And to make this even easier to see, let's go to a web console instead. So Fabric8 provides a little web console that can look inside the Kubernetes cluster and see what's going on. So over here we have a menu bar and controllers, that is the replication controllers. So we can look at all the replication controllers we have. And myweb, there's one replication controller called myweb, and that is the Tomcat replication controller. And there is the replicast 1, that is the desired state. So we want one of pod running with this application. And then the green one here is what is actually running. So 1 and 1, so it's healthy, right? And there is, for the CDI application, there's 0. And the desired state is also 0, so there's no CDI application running right now. So what we need to do is to deploy the CDI application. And I can do that from the command line with the Maven goal, local deploy, and I type that one, and it starts to build the product. It builds the Docker image, it generates the Maven Kubernetes manifest files, and then it deploys it into the container. And quiet time, nice. And the Docker image, Docker Maven plugin is building the Docker image now. Here it does, it takes a little while. And now it continues, and there's some Fabric8 stuff with the Kubernetes stuff, and it's done now. If we go to the web console now you can see it's actually CDI 1.1. So now that one is running as well. So we go back to the command line again. Up here, get pods, and now we should see there's also a CDI up here, my CDI. What we can do now is to follow the logs of that pod, my CDI, and we can see what's going on up here. It will log what's happening. So we can see here it's called with the count, and this is the name of the what the Tomcat is running, and it's the same all the time because there's only one Tomcat. So let's try to scale that up, and we say 2. And you can see here now there's one being, and one is waiting for Tomcat to boot up, and it's only ready when it's really ready. So what happens is the Tomcat application runs up, and when HTTP listener is ready on Tomcat, then it's ready. And now it's ready 2 and 2. If you go back to the log, you should see here it will change between the different of them. Now you can see it's different. And you may think it should be round robin, but it's not. It's actually, the Kubernetes guys found out that the best strategy for this was actually not round robin, but just to be random. So it will call these pods by random. Now, because everything is just Docker, you can just still use the Docker command. So I'm running a Docker PS to see the Docker container running in the cluster. And I will be an evil guy and just kill one of these web containers. So this is the Docker container ID, Docker kill, and then I'll kill that one. And pay attention to the screen on top, what's going to happen. Damn. So there was a stack trace. So something happened. And now you can see it will call the same container all the time. This is the same container. And now there's a second one. So there was a self-healing. So we killed the Tomcat container, the client failed one time, and then a little while later, a second Tomcat container was booted up and is ready again. And we go back and look here, and there's 2 Tomcats running and 1 client. But why did the client fail? And that's actually on purpose, because the Kubernetes guys and Google and the other guys realized that you should build clients on an access service with the state that it can fail. There's nothing that is, super always working. So you as a client should actually be aware that even though you call a service into Kubernetes clusters, it may still fail. So you need to build some resilience into your client. And for that, we can do this in Camel. Camel supports something called on exception handling. So we can say if there was an exception, then try to call the service again up till 5 times and with 2 seconds as delay in between. So we build that in the Camel application. We go back here and we build the product again with the local deploy. So we'll compile the code, build a new Docker image, generate the Kubernetes manifest file, and then deploy that. It takes a little while, and we can just go here and wait. So instead, let's go and look at the web console, because it will build, and you should see down here the CDI. That line should change when it's actually redeploying it. So let's see if that happens. And it actually goes fast, so it might. Now there's a change. Now it's changed. We go back to the log, and oh, what happened here? So we redeployed the client, and what happened is that Kubernetes will kill that pod and start a new pod. So the Java CDI application actually shut down. And you can see that from the logging, you can see Camel stopping and so on. But if you go and look at the pods, then there's a new CDI application running over here. So we can follow the logs of that guy now. And now it's running here again. And it's calling the Tomcats. But if we are being a nasty guy again, try to kill one of the containers with the Tomcat. Let's find one. You have to find the right. Here's one. Docker kill. And we kill one. And up here in the client, it should just continue. It calls all the ones, but what pay attention is still, now it's only one Tomcat running, so we'll stay using that one. If you go and look on the web console, we can see a second one is about to come online. Still waiting. Tomcat is booting up. It's not so super fast as the others, so it takes a little while. Still not ready, still not ready. Come on. Yes, now it's ready. And we go back and they will call each other. So that's sort of way how you can build a microservice in a Kubernetes cluster using Java in a sort of more like a resilient way. You have to think about that the service call can actually fail, so you have to build in some sort of redelivery. With Camel, that's fairly easy with the error handling on exceptions. Other Java libraries have something similar like that. There's still time to see some other areas of the web console. For example, you can see here, you can see all your service running. The web hello service actually also exposed on a DNS name, so I can actually try it from my web browser. This is my Mac computer that is talking into the Maven image where the service is running. And this is the Tomcat application we are calling. And I can call it with Camel hello, and I can give it a name, say name, Java Dev Riga Cinema 10. And it will say it, Java Dev Riga Cinema 10. That was me and you. The console again is over here. There's a nice little diagram. You can see your replication controllers on one side, your host and ports on the other one, and the service. And if you scroll down, you can see some Camel application. Sometimes it overlap. So this is the Tomcat application. It's actually running on two ports, and it has a service over here, hello service. You can see how they're linked. And then there's the CDI application. The client is not exposing a service. And there's also the possibility you can actually also look inside these JVMs with this button here. So it's actually using that hot IO console that I was first demonstrated, and you can see the Camel stuff here as well. And just to finish off with a little fun thing before we take questions, there's something called the Angry Pods. So there's a little game you can play where you can shoot your pods. So, and they shoot back at you, so you should, there's a Camel one, let's kill it. Yeah. You motherfucker. Now I killed it. But they can also kill you. Currently, sadly, the game doesn't have a blacklist, so actually some of the pods are like the web console itself, so you can actually kill yourself, so that's maybe not a good idea. So we are currently working on, blacklisting some of these out of the box, and then you can maybe, when you start the game, say, I only want to play against these pods. And also the maze is a bit too big now, so you can actually walk around a bit and don't see pods, because I only have like 5 or 6. So we are working on making the maze bigger and smaller as well. So, but the idea is that you should have some sort of social event to do things, because building distributed application where things can fail, that should come natural to you. So you should actually try to test that. And if it fails, that's only good, because the Kubernetes cluster should be able to self-heal. And you as a client that build these applications should build in resiliency, as we did with the Camel application. There's also something called a chaos monkey. If you heard about Netflix, they actually have something that runs on the production service and kills things by random. You can apply that as well from Fabric8, and it goes exactly the same. And we have a chat room where it can actually go into the chat room and the chaos monkey and say, hey, I killed this one, I killed that one. And we have a bot in the chat room, so you can actually manage your cluster using the bot. So you can just chat with the bot and it can go around and do stuff for you. And this is sort of like the social event that we would like to work on. And you can actually try, if you run the console, there's a run button here. And you can see some of the out-of-the-box stuff we have. You can install them. There's the Chaos Monkey. You can install that by clicking that button. There's some chat ROM here. But let's just finish off trying to install the metrics one. So I can install a metrics and run. And it will install Grafana, and it will capture all the utilization metrics of your pods, like CPU, memory, I/O, and whatnot. And then you can show them in the Grafana control. And there's Grafana service here. I click that one, and it comes up here. And there's a Kubernetes pods, for example. I can look at the pods. And last 6 hours, we just started, so last 5 minutes. I just started, so the graph is only here, right? And we can find our own pods. There is, where's myweb, for example, that is the Tomcat one. We can actually see Java is eating quite a lot of memory, 400 megabytes or something like that. And there's same things for centralized logging and whatnot. And you can build your own application to get into that list as well. Let's cut here because we should probably have time for some questions. So any questions? Yes?
What's the recommended way of encapsulating a process? What's the recommended way of encapsulating a process in, yeah.
What is the recommended way to encapsulate a process? So is the process Java-based or any kind of, yeah. Well, you can say that Linux container is a very good way of encapsulating process because a Camel question, okay. So are you talking about a Camel process from the ERP patterns? Yeah. Okay. In Camel, there's an API called a process which you can implement in Java code that Camel can call and give you a message and exchange. And you want sort of isolate that one. So you want to reuse it, or what do you mean by isolated?
Because you have different ways of describing the API of a process. Like how you're taking parameters, after the exchange, and each one is quite dirty.
Yeah. Okay, so the question, that is you can say the cons of using the Camel process API because it's a low level, you work on the exchange directly, there's only exchange parameter. The idea is that you can actually use Java beans instead. So you specify your Java method signatures of the bean with the input parameters as you want, with the message body and headers, and you can map to those. So you call the bean instead of using a process because the process is rather low level, as you said. Otherwise, you'll have to document that process and say, it requires these headers and whatnot. Other questions?
Do I correctly understand that Kubernetes cluster has own service registry as opposition or competitor to Zookeeper cluster?
So yes. So Kubernetes itself has its own service registry, and it is a competitor to Zookeeper. I think it's the same idea with a highly available distributed service registry or registry itself. The Kubernetes service registry is not implemented using Zookeeper. Zookeeper is Java technology. Kubernetes is more Go as the primary language, and they have the registry is implemented using something called etcd. That is part of the nodes, and it's the same idea actually. It works so you will use that one, but it doesn't mean that you cannot run Zookeeper in your Kubernetes cluster. You might use Java applications that rely on the Zookeeper and whatnot, so you can actually still run Zookeeper inside your Kubernetes cluster if you want. One more question, maybe the last one. Oh, you can win you will ask the first question.
So regarding kind of the development time overhead, the the deployment takes some time, right? So, you know, how would I do that in day-to-day development? Is there a lighter way?
Yes. So the question was, is there a lighter way for doing the day-to-day development? Because there's building the Docker image might take some time. So the Docker Maven plugin actually has a functionality, so you can sort of do a diff build, or you can push changes directly into the running container. So I would recommend you go and look up the Docker Maven plugin, and it has quite extensive documentation how it works and other goals. So you can sort of run it in a different mode where it's sort of, when you do a code change, or you can sort of monitor any Maven dependency that your product uses, and if these Maven dependencies are changed, then the Docker Maven plugin reacts and updates the running container. And it can also push changes, for example, that are not code bases. So if you have sort of like a HTML file or something like that, you can also just swoop that in as a new one on the fly. Okay, I think time's up. Yeah, thank you.